Most modern intelligence work is not about reading messages, it is about analysing patterns. In today's digital environment, metadata often reveals more than content. So how does UK intelligence use metadata to detect terror networks? And what exactly is metadata in the first place? This video explains how communication patterns, network links, and digital footprints are analysed to identify potential threats without necessarily reading private messages. First, let's define metadata clearly. Metadata is not the content of a message, it is the data about the communication. Who contacted whom? When? For how long? From which device? From which location? How frequently? If content is the letter, metadata is the envelope. It describes the structure of communication, not the words inside it. Why is metadata powerful? Because networks leave patterns. Even if messages are encrypted, the structure of connections can still reveal relationships. Repeated contact between known extremist accounts. Rapid expansion of a cluster of new identities. Communication spikes before travel, multiple devices linking through the same identifier. These are not conclusions. They are signals, and intelligence analysis begins with signals. In the UK, metadata analysis operates within legal frameworks. Collection and use are governed by statutory powers and oversight mechanisms. Authorisations are required. Judicial review exists. This is not random mass monitoring. It is targeted analysis, often triggered by prior indicators. For example, open source monitoring may identify an online persona spreading extremist propaganda. That persona may already be known to authorities. Metadata analysis can then map its communication network, not by reading every message, but by identifying patterns of contact. Who interacts frequently? Which accounts are central? Which are peripheral? Which new nodes are emerging? This is known as link analysis. Link analysis turns raw metadata into network maps. Imagine a visual graph. Each person or device is a node. Connections between them form edges. The thicker the connection, the more frequent the interaction. Over time, clusters become visible. Influencers appear at the centre. Recruiters show repeated outward links. Operational coordinators connect across clusters. Patterns reveal structure, and structure reveals hierarchy. Another key component is temporal analysis. When do communications intensify? Are there coordinated spikes? Does activity increase around specific events? Timing can indicate preparation stages. It can also indicate mobilization. Metadata allows analysts to detect changes in behavior, a dormant account suddenly communicating daily, a new device connecting repeatedly to known subjects. Cross-border communication increases. These are behavioural shifts, and behavioural shifts matter. Encryption has changed the landscape. End-to-end encrypted messaging platforms limit access to content, but encryption does not erase metadata entirely. Device identifiers, connection timestamps, routing information, session durations, these still generate structural data. That structural data can be analysed lawfully under specific authorisations. Again, the distinction is important. Reading content requires one level of access. Analysing communication patterns requires another. Metadata analysis often comes earlier in the detection chain. Metadata alone does not prove criminal activity. It indicates risk, it suggests association, it highlights anomalies. If risk increases, the case may escalate. At that stage, further investigative tools may be authorised. Surveillance warrants, device seizure, digital forensics, financial tracing, but the first signal often comes from metadata. Another important element is network expansion modelling. When one subject is identified, analysts examine who else communicates regularly with them, which contacts are most active, which accounts overlap with other known clusters. This creates a layered map of relationships, not just one-to-one links, but network ecosystems. Terror networks rarely operate as isolated individuals. They function through support systems, facilitators, recruiters, propagandists, financiers. Metadata can help identify those roles, not by reading intent, but by analysing structure. Geospatial metadata also matters. Location data from devices can reveal travel convergence. Two individuals from different regions meeting physically. repeated device presence at the same site, cross-border movement patterns. Again, this data is used under legal authorisation, and again, it is analysed as part of a broader intelligence assessment. It is critical to understand that metadata analysis is probabilistic. It identifies patterns that require further evaluation. Analysts must distinguish coincidental contact from coordinated behaviour, shared ideology, from operational planning. Volume alone is not evidence. Structure and context matter. In the UK system, intelligence derived from metadata is assessed before it becomes operational action. If sufficient concern exists, the case may move to active investigation. If evidence emerges, it transitions into policing. If charges are authorised, it enters the court system. Metadata may start the chain. But prosecution requires admissible evidence. That distinction protects both security and due process. So how does UK intelligence use metadata to detect terror networks? By mapping communication structures, by identifying behavioural shifts, by modelling network relationships, by analysing timing and clustering, and by integrating those signals into structured risk assessment. It is not about reading every message. It is about understanding digital patterns. In a world where communication is constant, patterns reveal more than individual words. And in modern counter-terror work, prevention often begins with structure, not content. If you want to understand how those intelligence signals turn into investigation, disruption, or prosecution, those stages are explained in the wider UK counter-terror series on this channel.